Hello, YouTube. So, this is something I wanted to share with the repair community. This is a known procedure and a known way to troubleshoot this issue. Um, I got this 34470A on eBay for relatively cheap because it had a failed firmware update. If you have one of this series of meters, 344, 6X, or 7X, and they're still on any version of the 1.x firmware, be aware that you cannot directly upgrade them from 1x to 3x. It will kind of brick the machine. It is fixable, but it can be kind of a pain. So we'll turn this on. It will take longer than normal to boot because there are software conflicts going on. Normally, boot is about 20 to 30 seconds. In this case, it'll be closer to a minute or more. So this is one where, in terms of interpreting from symptoms, it would have been on a 1.x firmware, and someone tried to do what honestly I've once tried to do, and this is how I learned about it. Go directly to the latest firmware, which for the most part you would think would be logical. But it does cause problems. You need to first go to firmware 2.17, and that is a non-reversible firmware upgrade. You can't go backwards once you're there. However, if you install a 3.x and it fails, you can revert back. Not in here, but you can downgrade to 2.17. And specifically 2.17 is the firmware you need to downgrade to. Now, my computers, you saw a double beep. Firmware update failed. Current version is A.03.03. So basically 3.03. After a little bit, it's going to give us one more beep, and then it'll basically not work for most functions. So, and then another one, sure. If we go over to the Keysight website, you look up the firmware. Current version, which was released in 2021, is 3.03. That's what you want to get to eventually. Now, I'm not using the Windows method because I'm not on Windows, I'm on Linux. So this is the method I've used. Let's turn off notifications right now. I went to previous version, right here. The oldest version they make available is 2.17, and for good reason, you need that. So we would download this. Go over here and download that. Now, I did have to boot up my field laptop to use the Windows partition to extract this, and I'll show you why. Let's go to... where is it? What, did it not save? Alright, well I still have it up on Firefox. So here's the instructions for updating by front panel USB, and this is what I've used. It's worked for me, so this is what I'm going to show you how to do. On a Windows computer, you basically run the firmware update utility, and it will take you through preparing a thumb drive. Basically, all it does is format it. I think it just formats to FAT32. And it then puts your firmware version. It will, no matter what meter you have, it will create a folder that is 34461A. It doesn't matter if you have a 65 or a 70, it'll create a 61A folder, and it will put two files in it, build.xml and nk.build. It will not tell you what version they are, so you can't know by looking at that. If you know what size they are, like I do, then you can tell just by saying, like, how many megabytes is this? But yeah, it'll make the folder named 344618A, and it'll put those two files in it. Then you want to go to, if you can get in, because some bricks are worse than others. Shift utility, test admin, security. Mine froze when it got to secure code. I'm betting, however, that it's in unsecure because someone already tried to update the firmware, so it still should be unsecured. So what you do is shift utility, test admin, and you would go to firmware update. And that you can do by the front panel. So we'll go over here and see if it'll let us do that. Now, I have a couple of 61As, and I had to do this on one of those. And my experience was the meter would just freeze multiple times, and I just had to keep trying. I think it was on the 4th or 5th time that it finally took. It might be that if you leave it long enough, it will freeze completely and you have to reboot and then try again. So this has the 344618A folder. Let's plug this in. Shift. All right, it's still responding. I can hear it go, the tiny little beep. Utility. Test admin. Firmware update. It may have frozen. I heard the chirp when it responded to this button, but it's not moving. There we go. I was about to say, when you're in this kind of situation, if you hear it respond, you wait. An unreasonably long amount of time. You wait. Because it's not operating well, and it's not going to be speedily responsive. So, this will update the instrument firmware. Continue. Yes. Updating firmware. Do not power down. For the love of all that is beloved by the flying spaghetti monster, do not lose power. If you have a storm, be paranoid and just don't effing do it. If you have a UPS handy, plug it in through the UPS. And be very patient. Wait for it forever. The firmware version of blah 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 is older. Continue? Yes, because this is 2.17. When you have this problem, this is what you need to downgrade to. So click on yes. We heard the chirp. It did receive that command. It's updating firmware. Once again, if it's going to sit on here for 2 hours, walk away, make lunch, go for a nature walk, leave it be. All right, it's looking like it's not going to take too long for us right now. But whatever it does, wait for it. If it stays on one screen for a while, you wait. If it stays on a screen and doesn't move for an hour, give it another hour. Specifically when you're in the midst of an update process on the firmware. If necessary, leave it alone for a day and see if it finishes processing. It's the one time in which you are most able to do either irreparable harm and permanently brick it, or brick it to the point where you'd have to begin desoldering chips and putting them into a programmer to, use that as their method to delete information and manually load firmware. You don't want to do that. Absolute pain in the ass, and there's so much more that can go wrong. So, you just wait. Firmware update failed. Current version is 2.17. So, this is progress. This is okay. We still want to go through and do this. So, now that we're on here and it says firmware update failed, like I said, I had to do it multiple times. So what we do is we just do it again. Shift, utility. And it's actually responding faster, but it's still, neither here nor there. Actually, let's see if we can get a self-test. So, test admin. Nope, cancel. I was not patient. I pressed a button. I thought it wasn't responding. Bad on me. Cancel. Self-test. Quick test. And we wait. So, if I was just doing the repair, I wouldn't usually be bothering with this. I'm mostly doing it to document as much as possible for this video to show what the various states show as. It may make it long though. I tell you what, you don't need to watch all of this. You can see the current time there. I'm going to pause and then I'll resume once this is done. Okay, so the waiting for hours or a day is the part where you give the meter every possible chance to not fail mid-firmware update. In this case, we're just trying and failing to perform a self-test. You don't have to wait for hours to let it do that. In this case, it has hung on the self-test. We're going to try to exit out. It probably won't let us. No response. So we'll reboot. No response to power press. Let's try power hold. It responds to power hold. And let's boot back up. Okay, so we've rebooted. We're at that same message. So we're not going to try the self-test again. We've seen that it freezes there. So we'll go Shift, Utility, Test Admin, put this in, Firmware Update. And as before, wait patiently. If pattern holds from its behavior last time, it'll take 15-20 seconds, maybe. I'll come back to this. All right, this will update the current or instrument firmware. Continue. Yes. Do not power down, and we wait again. This is the part where you give it however long it needs. If it's, frozen after like a day, okay, you're alright to give up at that point. But that's how long you give it to like eke out that last 10th of a percentile of possibility of not bricking it. I rolled my chair away. I think it had not been on the screen yet. So, older than current firmware, it had not, I believe, fully downgraded or successfully downgraded because, we're still getting the error. So, continue? Yes. All right. So, attempt number 2, and remember it took me like 4 or 5 times for the 61A that I did previously. That one was kind of nail biting because I bought it used but functional, and I didn't know about this problem, and I was the one who effed it up. So I was like, this really nice meter. I just killed it? No! So I remember I was kind of anxietous when I was trying to figure out, hey, what did I do? Why isn't it? Why can't I fix it? And eventually I found out how. And then further anxiety when it's like I followed the procedure to fix it and it failed. And I was like, wait, is it bricked? I permanently killed this thing? But no, you just keep trying. So we have, once again, firmware update failed. So, very well. And we will do it again. Firmware update. And we'll also try different things in between, like fully powering it off, that kind of thing. Yes. Another thing we'll try is waiting for that double beep, because before, when I booted it, there were a few more beeps that came along. I'm guessing certain boot processes had to wait for... Oh, hey, we have something new. I didn't read that in time, but I saw it come up. But actually, I can merge files. I'm going to stop and look at the recording so I can read that message. Okay, so this is part 2. I'll merge the files later. So the message that came up briefly and then went away were controller and measurement board model numbers do not match, or it might have been slightly different wording, but that was the same thing. That's a different issue than I've had before, but I have read about this one. If you have a Spear MCU failure is common in the front panel. That's where the Spear MCU is, and until they stopped using that one, I think it was 2014 or 2015, the serial number is beginning in 54, so this is a 2014. Until they stopped using that specific, that front panel controller, the Spear MCU, it was a high failure rate item, high enough to be significant and undesirable. And it's the known primary cause of the white screen of death in these. So it looks like what happened is someone either replaced the whole front panel or replaced a donor board. Or maybe this is the original front panel and they had the main board in there die and they took a donor main board. But either way, this machine has a front panel board from a different machine than the main panel board. And what Keysight did, just like Apple, was they did serial number cross-matching and security checks so that you can't repair your own shit. This can be fixed. It has to be done by manually deleting and editing firmware with a programmer. Like this. So I actually do have the programmer that I need to do this. This is a separate issue, and then someone tried to... They probably thought that, hey, if I just reinstall the firmware, I should be good. So they tried that, and then either the firmware update, or rather reflash, failed because of the mismatch between the boards, or they also had the issue where it was originally on firmware 1.x and they installed 3.x and then added the problem of the firmware failure. But I have a contract job I'm going to get to. This will be a longer thing to do because it's much more involved to basically hack this thing, because at this point it is hacking the damn thing and telling it, hey, you're wrong about what serial number is embedded in your firmware. This is the serial number you're going to remember from now on. These are not the droids you're looking for. Fuck you, Keysight. Fuck you, Keysight, and your anti-repair. I mean, who do you think your customers are who buy these high-end multimeters? People who don't want to repair stuff? Jesus Christ. All right. So, sorry about that. We'll call that part 1. So I showed the fix for if it's just a firmware error, you would, keep doing that. But because it is a board model number or serial number mismatch, we'll edit the firmware later and get this fixed. But for now, I'm going to clock out for bench work. I'm going to take care of my field work, and then I'll be back. Bye. So a quick bit of follow-up. I wanted to check, I was reading through the article that someone else had written for when they had to deal with the mismatch between the board and the measurement board and the front panel. And they were describing what errors were shown. So they were describing error 822, controller and measurement board serial numbers do not match. What I saw looked like model number, and I wasn't sure if they had just typed it wrong, if I'd remembered it wrong. So, again, for this specific situation, I booted it. I went to Shift, Help, down to View Errors, and went, Enter errors. And it said none. But it had just booted, and it hadn't gotten to the point where those 2 extra beeps came in. So I had to wait a little bit longer. And after the first beep, waited more, then there was another beep. Not the boot up beeps, but the ones that happened a couple minutes later. And then I went to errors again, and I got this. Plus 821, controller and measurement board model numbers do not match. 320, slave processor communication error, command return error status. 320, basically just repeating 320, slave processor communications error, communication restart failed. Returned error status, restart failed, returned error status. So this was the slave processor communications, like failing, seeing that it failed, and trying to restart. Oh, we have something else here. 615. Self-test failed. Measurement processor not responding. So that was probably when we tried to do the self-test and it just hung. And that's it. Okay. So this was just of our own making when we tried to do the self-test. Yeah, measurement processor not responding. Okay. So this is a little bit of a different one. Model number different versus serial number different. We might be able to still fix it. I will consult with the EEV blog HiveMind, and we'll see what we can do. Okay, part 2 of this repair for the Keysight 34470A. I bought this as it was described as a failed firmware update. But what's really going on, I believe, is someone replaced either the main board or the front board, because it was giving error 421. Let me see what the exact wording was. Controller and measurement board model numbers do not match, and a repeating sequence of plus 320, slave processor communications error, command returned error status, and plus 320, slave processor communications error, communications restart failed. Let me bring this up. So I'm going to bring you over to a picture that I took of the error message. So this seems related to something else another EEV blog user has run into, which is error 822, which basically says the same thing, except instead of model number mismatch, it's serial number mismatch. And that has been described as something where they went in, they desoldered the NAND, they extracted firmware, they edited part of the firmware to get rid of the serial number, because Keysight serial number locks the components together so you can't repair them, at least not without extraordinary measures. I don't know why they would do that. I feel like they don't understand the market for their instruments. We are people who repair things. Yeah. So, before I open this up, serial number starts with 54. Does say 70 back here as well as in front. Serial MY547000619. And I'm wondering if everything on the inside is going to appropriately match. Maybe not the serial number, but I wonder if there are non-70A parts in here. No, sorry about that. So let's gently take these off, preferably without hurting the little retainer nubs. If you're taking I may as well explain. If you're taking these off, you want to get one side first and be as gentle as possible. You want to try to pull one corner out and lift just a little. Then you want to take this other corner, pull out and lift. Because they're little rubber nubs, and if you just pull, they start to like just shear away and cut bits of them off, and they degrade. That's the most common reason for a lot of damage. I mean, it's not somewhere you can see, but it's still something you don't want to do. And there we've lifted just sideways, so that now you just pull this way and up, and then like that. So you can see that's happened previously, where that nub has gotten damaged, and that it's really common to see. Yeah. We'll do the same here. And the back one, there's different iterations of this mold I've seen, but in this one, it's kind of more smooth and that's a better design. I think this may be a later iteration where they realized, oh, hey, that happens a lot, let's fix it. And instead of little nubs, they have one ridge here. So this is the better model. Although I don't know if I've ever seen that design on the front panel molding, or the bumpers, so yeah. Alright, so we want, I think it's T15 and T20 Torx. T15's for the back. No, T20. Something else, when you put these back in, you want to be careful not to over tighten because they get stress cracks right here. At least it's that way on the 34401A and the Agilent 531 3X and 8X series frequency counters, and a bunch of other instruments that use this type of case retention design. So that's a little snug. So before we pull it off, okay, so it's all T20. For some reason I thought there would be one that was T15. Maybe there is on earlier models. So I'm curious what we're going to find when we open this up, because I'm guessing hardware has been swapped. That's what those error messages will indicate. I'm looking on the inside of the case, and I don't see... basically, I was looking for any evidence of burns or burn marks. I don't see any, so that's fine. Now, let's just quick check this. Yeah, I have mic levels good. Kind of late to check that, but all right. What do we have here? 34465. The main board is 65, not 70. This is not a 70. I will check with other EV blog users, but and I'll see if I can find, like, maybe Dave did a teardown on these, but that right there says 65. And I purchased a 70, which, I mean, the outside is. The front panel, I'm almost sure is too, unless I disassemble it and it looks like something's been, like, reflowed or soldered off of it. But the front panel, like, it displays 70 when it boots, but the front panel is where you have, like, the user interface firmware and such. So that's the portion that would say 70 anyway. But this is the money right here, what gives you 7.5 digits instead of 6.5 digits. And this is saying 34465. All right, I'm going to stop here. I'm going to stop, get pictures, and consult. Okay, so this is going to be the closeout portion of part 1. In the last section, I was looking between the numbers on here, and I saw on the silk screen this said, 34465A, and I was wondering, hey, is this a 70 instead of a 65? It is. The PCB itself, not the components, but the PCB itself is the same for the 65 and 70, and then the difference isn't just the voltage reference, it's a bunch of components that are changed or added. I referenced Dave's teardown on the 34470, and he did a lot of side-by-side, back-and-forth comparison between the 70 PCB and the 65 PCB and how it's populated. So it is the right PCB and silkscreen. That's expected. And how you tell if it's a 70 is there's a smaller sticker right there. And I'll see if I can get this on screen. So, okay, I can't really zoom in. But right down there is it's basically the board serial number sticker, I believe. And it does start with 34470. So it is a 34470 main board. So that leaves us most likely with, probably it was a 70A that had a Spear MCU failure, which is like the most common thing that kills these, at least in the white edition. I think they stopped using that MCU in last year, 2015 or 2014, something like that. I know it was no longer produced after Texas Instruments realized they had a lemon and they, discontinued it. But yeah, I think it was Texas Instruments that had bought the parent company that made the Spear MCU, which is what, STI or ST, whatever that is. But I'm like halfway remembering the history behind that. Anyway, that MCU stopped being made in a certain year because they realized it was a lemon and it was, failing pretty often. So most likely this 70A had a bad MCU and someone tried to repair it by swapping maybe not the entire front assembly, but the PCB. I don't think that they like. Well, it does not look to me like the Spear MCU was desoldered and resoldered, like, unless it was done extraordinarily cleanly. And even if that was, that's the proper way to do it. That would result in a working unit. So one of these other chips, I think that's just a coil. Yeah. Oh, anyway, U402. Oh, maybe it is a chip. There's some evidence that maybe this one was soldered. So, I mean, I have a little bit of flux on the sides. Maybe. Anyway, most likely what I was thinking is that someone just swapped the entire front board. And Keysight serial number locks. Like, the front boards come as something without a paired serial number, I believe. And then the first measurement board that they're connected to, they read the serial number off the measurement board and they lock to that serial number. And then it's this whole pain in the ass process of rewriting firmware to erase that serial number. But yeah, that's the going theory, that this is what was replaced, this board. And this follow-up is just, this is a 70A main measurement board, so that almost certainly, or that's not what happened. My initial reading of the silk screen, seeing 65A and wondering, is this a 70A? It is. Alright, so that's the end of part 1. I have some posts and discussions on EEV blog, consulting with people who have resolved similar issues, and we will go from there at a later time when I have more information.